Let us solve the next sum. Before solving that, we will read the question well, then we will solve it. What is the power of a concave lens? Here concave lens is mentioned. If concave lens is there, its focal length will be negative. We have to take care that whether concave lens is there, convex lens is there. If it is convex lens, then focal length will be positive. If concave lens is there, then focal length will be negative. Similarly, if concave lens is there, then power will be negative. Convex lens will be there, then power will be positive. So here now concave lens is given, so its power will be negative. Concave lens, power negative, focal length also negative. Now, and what is said here? What is the power of a concave lens? We have to find out the power of concave lens. Then, required to correct the vision of person's eye whose far point is 50 centimeter. Here, far point means focal length. That is given, but they didn't mention here whether it is positive or negative value. Here now, seeing this lens only we can understand that focal length. Far point means a focal length. Near point means again focal length. That will be positive or negative. So here now concave lens given, so its focal length will be negative. Once focal length is negative, then its power also will be negative. Let us solve. Here power you have to find out. Power of which one? Concave lens you have to find out. Now they given here far point given, that is focal length given. How much? 50 centimeter. You have to see that this is in centimeter given. Even here concave lens is there. Because of that we have to write here minus. Concave lens, because of that far point or focal length we have to write as minus. Now here centimeter given. Always while calculating the power of a lens, we have to write the focal length in meter. So here centimeter is there, we have to convert that centimeter value into meter. For that, minus 50 upon 100. So your answer will be minus 0.5. Zero, no need of showing this much meter. So we have got now focal length of this concave lens, that is minus 0.5 meter. Now we need to find out the power of this concave lens. So for finding the power, we can write as P in diopter. That is equal to 1 upon small f, that is in meter. So here now P, that is equal to 1 upon, here f we have already found out, minus 0.5 meter. Now this decimal we have to remove, multiply with 10. Similarly here also you have to multiply it with 10. So P is equal to 10 upon minus 5 meter. So here your answer will be now 10. This value 10 upon minus 5, this you can write it as even minus 10 upon 5 meter. Now here 10 divided with 5. Our answer will be 2. So our answer is now 2 diopter. So here now power of the concave lens is how much? Its answer 2 diopter. Which 2? Here minus value is there. Then we have to write here minus 2d. D means a diopter. So therefore power of the concave lens equal to minus 2 diopter, 2d. Let us solve the next sum. Before solving that, we will read the question. A 5 cm high object is placed at a distance of 25 cm from a converging lens of focal length of 10 centimeter. Determine the position, size and the type of the image. Here, a 5 centimeter high object. It's a height mentioned, that is 5 centimeter. So height of the object we can write h1 is equal to 5 centimeter. And this object is placed at a distance of 25 centimeter from the converging lens. Converging lens means convex lens. This is the optical center. Through that one line is passing, principal axis we can say. From this object, always object we have to keep, this is the lens. Now from this lens, always we have to keep, every time object distance will be negative y. Object we have to place at the left hand side of the lens. So here now from this lens 25 centimeter far, that distance we can write as u, that is equal to how much? 25 centimeter. So object distance we can write as small u, that is equal to 25 centimeter. One more thing we have to take care that object distance always will be negative. Why? Because it is keeping at the left hand side of the lens. Because of that u always will be minus or negative. Then here it is mentioned converging lens. That means it is a convex lens. Now again given it's a focal length. Focal length of a convex lens always will be positive. So f, small f, that is equal to 10 centimeter. Focal length of a convex lens will be positive. Distance of u always will be negative, whether it is concave lens or whether it is convex lens. Both the cases u will be, u means distance of the object, that will be negative. Now determine the position, size and type of the image. Now you have to find out where, that means the distance of the object given. Now distance of the image you have to find out, that means v you have to find out. After that what will be the size? Size of the image you have to find out. Size means height of the image you have to find out, that is h2 you have to find out. Then one more thing they said, what is the position of the image? Position means we have already studied, that is the distance of the image. Size means the height of the image. Then other question, what is the type of the image? Type of the image means nature of the image. Nature of the image, whether it is a real image or whether it is virtual image. Real image will be there, then that will be an inverted image. Now here this particular side, that means the right hand side image is forming. Image value is positive. That means the right hand side will be there, image value will be, distance of the image will be positive. If the distance of the image is positive, then the image will be an inverted one as well as a real one. So we can say that here, if the image is forming this side, that means the right side will be there, then you will get the answer positive value. If the positive value is there, image distance, if you are getting positive, then you can write as it is a real image and it is an inverted image. Height then you have to find out separate. Then here now first we will find the value of v. For that we are having one formula with us, that is 1 upon f is equal to 1 upon v minus 1 upon u. Now from this we have to find the value of 1 upon v. 1 upon v is equal to 1 upon f plus 1 upon u. Here minus value is there, that is coming to here. Actually means we can write it in such a way also, that is 1 upon v we can, here I am writing, therefore then 1 upon v I am keeping here, that is equal to 1 upon f, then this value I am taking to other side of the equal to, so that is equal to 1 upon u. Same value I written here. That is 1 upon V is equal to 1 upon F plus 1 upon U. Here 1 upon V this side I written. Here 1 upon value this side I written. But answer will be same. Now we have to substitute the values. 1 upon V that is equal to 1 upon F. 1 upon F that is 10 plus 1 upon U. 1 upon U value means that is in minus 25 centimeter. Now here again I am writing 1 upon F that is equal to 1 upon 10 plus into minus 1 upon 25. Now we can cross multiply them. So 1 upon V that is equal to 25 minus 10 upon 250. Now here that is equal to 15 upon 250. Now here both the places 5 will go. Here 5 3 times will go. Here 5 50 times. Now therefore V is equal to, we have to write the reciprocal, that is 50 upon 3. That is equal to, we have to divide 50 with 3. 3 in 5 1 time 3. Now 5 minus 3 2, 20. In 20 it will go 6 times. 6 3s are 18. Now 2, here decimal. Here I am writing now 20. 6, here 18. Now same way it will be continued. So 16.666, like that it will be there. So our answer is now 16.666. That we can write it as 16.67 centimeter. Now the value of V we have got positive. That means image formation V is forming this side. How much distance? At 16.67 centimeter far from the convex lens it is forming. So we can write here position of the image we have got, that is V is equal to 16.67. Then type of the image we can write, that is, first we can write position of the image. Position of the image. Position of the image, that is V, that is equal to 16.67 centimeter. After that, type of the image also we can write. Here the answer is coming positive, right hand side. That means now we can write a type of the image. That is only the nature of the image. Type of the image. 2 dots. Then we can write real and inverted. Real and inverted. Now one question that we have to solve it, that is size of the image. Size of the image, that is H2. We need to find out. That I have already written here. So we can write now H2 is equal to. That means H2 upon, we have one formula with us, that is H2 upon H1, that is equal to V upon U. For finding height of the image, size of the image said, that is height of the image. For finding that we have one formula with us, that is H2 upon H1, that is equal to V minus U. Now here H2 we don't have, H1 we have. H1 that is 5 centimeter. Then that is equal to V, we have already got it, that is 16.67 centimeter upon U. U we have got, that is minus 25 centimeter. Now from here we have to derive H2. H2 is equal to, here now division form is there. When it will go to that side, it will be in the form of multiplication. So 16.67 upon minus 25 into 5 centimeter. Here 5 means 5 centimeter, then u as well as v, everything in centimeter. So you can put the value here centimeter. After that we can cancel this thing, 5 in 25, 5 time will go. So our answer now H2 is equal to 16.67 upon minus 5. Now here this value we have to, if you are writing here minus or here minus, one and the same meaning is there, so we can write it as minus 16.67 upon 5. Now here 16, these decimals we will remove by multiplying with 100. Similarly here also we can multiply it with 100. So our value will be minus 16.67 upon 500. Now we have to divide this value with 500. 1667 divided with 500. Now 1667 is there. In that 5 will go 3 times. 3 5s are 15, then 00. 7, 6, 1. Now we will put 1 0 from outside. So here 1 decimal. In that again 3 times it will go 1, 5, 00. Here 0, 7, 1. Now we will put 1 more 0. So in that again 3 times it will go 1, 5, 00. 0, 0, here 2. Now 1 more 0 we will put. In that it will go 4 times. So here we are getting the answer now 2000, 0, 0, 0. So here now H2 is equal to how much we have got? 3.334 centimeter. Therefore, height of the image, that is H2, equal to 3. Here one more thing you have to take care. Here minus value is there. That's the reason here we have to put the answer. In the answer also we have to put minus. Here also minus 3.334 centimeter. Image formed at the right hand side. Again you see height is minus got. That means the image will be an inverted image. That's the reason here minus value we have got. So here now we have got the position of the image, that is the V we have got. Afterwards what is the type of the image, that is real and inverted. Before only I have said. Now by seeing the height itself we can be able to understand the image is the inverted one. Then V, distance of the image formed where? Right hand side. Then image is inverted, because of that minus value we have got. One more thing, height we have got it. That means the size of the image 3.334 centimeter. Let us solve the last sum. Before solving that, we will read the question. The radius of planet A is half of radius of planet B. Radius of planet A. That means there are 2 planets here. A planet as well as B planet. Radius of A planet is half of radius of planet B. So we will write that thing. Radius of A planet, that is equal to half of planet B. Radius of B, how much is there? It's a half. Just you have to divide with 2. If the mass of planet A is Ma, mass of planet A, mass of planet A, planet A, that we can write as capital M, then below we can write capital A. What must be the planet mass of planet B? Now mass of planet B we need to find out. Mass of planet B we have to write. We have to find out. Mass of planet B we can represent as mb. Okay. Now just we can write mass of planet at present now. Planet will write as mb. We have to find out, but for solving we will write now mb. Next one. Here what must be the mass of planet B? So that value of G on the planet B is half that of its value on planet A. Now G, that means the gravitational force on planet B, that is equal to half that of the value on planet A. Gravitational force on A, how much is there? It's half. That means it upon 2. So once again we will study radius of planet A, that is half of radius of planet B. Planet B, its radius how much? Upon 2. Mass of planet A, ma. Mass of planet B you have to find out. So I written it as mb. We need to find that value. After that, gravitational force on planet B, that is half of gravitational force on A. Planet A, which has gravitational force Ga is there. Its half how much is there? That will be the gravitational force exerting on the planet B. Now we are having one formula with us, that is G is equal to capital G into capital M upon capital R square. With the help of this formula we will compare the gravitational force exerted on planet A with the planet B. So here now Ga, that is equal to capital G capital Ma upon capital R A square. Gb, gravitational force on B, that is equal to Gmb upon capital R B square. Now we will find the ratio of both the values, that is Gb upon Ga, that is equal to Gb value Gmb upon RB square upon Gma upon RA square. Now here GB here value of GB we are having, that is Ga upon 2. Now upon Ga value same we will write Ga, that is equal to Gmb upon RB, that we will write as it is RB square, same. Then we will write divided by Gma upon RA square. RA, its a value given here, RB upon 2 whole square. Now here this value division form is there. RA value already we have got it, that I written here, RB upon 2 whole square. Then we are having Ma same as that, only mass of planet A same to same, no changes there. Then one thing they given, gravitational force exerting on B planet, that is equal to Ga upon 2. Now here 2 division form is there, that thing also we will write in means multiplication form. How it is doing, you see, GA upon 2 divided by GA. So then I am putting down 1. Now this value, first I am clearing this value. So GA upon 2 then into 1 upon GA. So this GA and this GA I am cancelling. So we are getting the answer here 1 upon 2. That is equal to. Now here GMB upon RB square. Here this fraction form is there, because of that this I am putting in the form of multiplication. After that this value I am putting upside, this value I am putting down. RB upon 2 whole square upon GMA. The whole value I put it upside, this value I put it down. Now here half, that is equal to, similar things I am putting together, that is GMB. Now here G and G we can cancel, this and this I cancel. So I am putting now MB upon MA into, here RB upon 2 whole square upon RB square. RB upon 2 whole square upon RB square. Now half equal to MB upon MA into, here now RB upon 2 into RB upon 2, then divided by, here divided by RB into RB. Now what I am doing here, this form I am making it as RB means here RB upon 1, here also I am putting as RB upon 1. Here now only this particular value I am solving now. So RB upon 2 into RB upon 2. This I am making it is in the form of into 1 upon RB into 1 upon RB. So here we are getting this cancel, this cancel, this cancel and this cancel. Then which all values are there here now? Into MB upon MA. Then that is equal to half. Now here MB upon MA, then here 1 upon 2 into 1 upon 2 is there. So we will write it as once again 1 upon 2 is equal to MB upon MA, then into 1 upon 2 into 1 upon 2. Here 1 upon 2 and 1 upon 2. Now here our answer will be 1 upon 2, that is equal to MB upon MA into 1 upon 4. Here half is equal to MB upon MA into 1 upon 4. Now we will write MB upon MA equal to. Now here this value, that is 1 upon 2, then this value we are keeping as it is. This value we are taking to here. This value we are separating. That means MB upon MA, we are separating it. So this value we are taking to this side. So what will be 1 upon 2 upon 1 upon 4. Now MB upon MA, that is equal to 1 upon 2. Then we will write divided by 1 upon 4. Now MB upon MA we can write as 1 upon 2. Then this division sign will be changed to multiplication sign, then reciprocal 4 upon 1. Now this 2 in 4 2 times will go. So MB upon MA, that is equal to 2. Now from this we can understand that mass of planet B, that is equal to 2, then this will go there, multiplication sign will be there. So we can say that therefore it is equal to 2ma. So mass of planet B, therefore mass of planet B is equal to 2ma. That means the double of mass of planet A. That will be mass of the planet B.